Hi there, in this video we're going to be going through some ideas to do with the confidence intervals that we've been calculating for proportions, and in particular some words to do with those called margin of error, the margin of error when we do a sample, and some different kind of questions from the last video. So if you look at this diagram here, it shows us that we do our sample and we get an estimate. We might do a sample of 100 coins, let's say, and we might then say, well, how many heads did I get? So I got 53 out of 100 heads. So my proportion, p hat, in that case there, would be 0.53. And that's my value that I've got right here. Okay. We then created a confidence interval based on that sample value. And I showed you the formula, and you're given that formula in the exam. The margin of error is just the width from the middle to the top, or from the middle to the bottom of our confidence interval. Okay, so it's just important that we understand what that word means, the margin of error. So if you remember the formula said we've got p hat plus or minus z times this thing here. All right, so this width from the middle to the top is actually just this thing here. So this is the margin of error, okay? The z value times the standard deviation from our sampling distribution. Okay, so you just need to know that that thing there, that part of the formula there, is the margin of error. Like I said in the last video, the greater the level of confidence, the bigger that z value and the wider your confidence interval. So if you want to construct a 50% confidence interval, it's going to be really, really small, but it's not going to give you any information that's important, right? Really small, but we're only 50% confident that the true value lies in there. So we go for like 90, 95, 99% confidence intervals. Again, you can see in this graphic here, the idea of going on here, we've got our sample value. So our true population value, you can see is that dotted line. You can see our sample values are sometimes higher, sometimes lower. We've created the confidence interval. And in most cases, the confidence interval captures that true population value. Some cases it doesn't. You can see the two red ones at the bottom. One's way high, one's way low. A 95% confidence interval would say 95 out of 100 of those intervals would capture the true population value. You can also see that the width of these intervals is changing. And the reason for that is that sometimes we get different values of p, so they will change the value of the width of the confidence interval. So let's look at this example here. A random sample of 1,834 parents recently showed that 63% of them feel that they let their children watch too much television. Calculate the margin of error for the given proportion for a 95% confidence interval. Collect to 3 decimal places. Assume that normality applies. Okay, that's good. So let's work out what we're given here. P hat is 0.63. That's our sample proportion. Remember, we don't know what P is. Our population proportion, don't know that. That's what our confidence interval is trying to estimate. So remember, the margin of error is this part here, Z times P hat 1 minus P hat over N. That's the margin of error. It's just the distance from the middle to the top or to the bottom of our confidence interval. So for a 95% confidence interval, we know that Z is 1.96. We've got P hat. And we have got the value of N because we were told that 1834 was our value of N. So I'll just call that margin of error. Grab our calculator. And we get 0.0221 for our margin of error. So I guess you could say the way the media would report this would be a 2.2% margin of error. Okay, so sometimes you hear in political surveys that they're under the margin of error, which means that, you know, say 1.8% from the sample of people said they would vote for a political party. If the margin of error is 2.2%, then theoretically they could have zero support. Okay, that's what they're talking about when they say they're within the margin of error. In this example, we're actually given the interval. Normally I do square brackets. This one's got open brackets, but in this one here, we want to know what the margin of error is and the expected value. Well, what we need to understand here is that a confidence interval is symmetrical, so that the expected value, or p hat in here, will be right in the middle of these two values. So I guess by calculation, you just say p hat was 0.506 plus 0.594 divided by 2. So it's that value right in the middle here. So 0.506 plus 0.594 divided by 2. So it's 0.55. Okay. So that was our sample proportion. What's the margin of error? So here's my confidence interval like this. 0.55 is in the middle. The top value is 0.594. So that distance there is the margin of error. Okay, so 0.594 minus 0.55, so 0.044, or some people again would say the margin of error is 4.4%. All right, now here's two examples where you have to actually find the sample size based on giving you what the margin of error is. So we've got a 95% confidence interval. We've got the margin of error. So remember, here's our value of p hat. The top end, here's the lower end. So we're telling you in this question here that that distance from there to there is 0.022. So that is z times all of this stuff here is 0.22. Okay. 0.022, beg your pardon. There we go. So what do we need to know here? We want to know, taking the sample proportion as 0.5, find the sample size. So we want to find what n is. So 1.96, this is a 95% confidence interval, so if it's different, that value of z changes. Here we're saying this is 0.5, and we're trying to find the value of n. Now again, you could get your calculator out here. I'll go work through it if you didn't have a CAS calculator, because I think that's really helpful. So I would first do this. So let's do that in the top line. 0.5 times 1 minus 0.5. 0.5 times 0.5 is 0.25. Okay. So I'm going to divide both sides by 1.96. So 0.022 divided by 1.96 gives me this, 0.01122. Okay, I'm then going to square both sides. 0.25 over n is that answer squared. So it's around about that. Notice I'm keeping it all on my calculator here. I'm not using any rounded results. I'm going to times both sides by n. There we go. And then I'm going to divide both sides by 0.000126. 0.25 divided by that big long answer we've got in there, 1984.3. Okay, so the sample size, I guess you could say either 1,984 would be the most reasonable answer. You could say 1,985, but in this case, because they said the margin error was exactly 0.022, I'd be saying that our sample size is 1,984, 1984, a great year. Okay, the last question here, we've got an opinion poll, with poll spelt wrong. Opinion poll is carried out to estimate the proportion of the electorate of a country who will vote yes in a forthcoming referendum. This is important stuff because polls really generate opinion amongst the population. If people hear that 80% of people are going to vote a certain way, then people who might have a no vote, if you like, might just feel like, oh, I won't even bother, it's going to win easily. Opinion polls are really important, and they inform people's opinions, and they can change people's opinions based on what they think everyone else is thinking. So the way that we go about this is important. So, okay, so we've got an opinion poll. In a trial run, a random sample of 100 people were questioned. 42 said they would vote yes. Okay, so P hat is 0.42. 42% of people, 42 out of 100. Estimate the random sample size required to give a confidence interval of the proportion with a width of 0.02. Okay, here's my confidence interval. There's p hat in the middle, which happens to be 0.42. And the question says that this whole width here has to be 0.02, the whole width, which means the margin of error has to be 0.01, or margin of error 1%. So we really want, how many people do we need to sample so that our confidence interval is actually within 1% of the true value? Okay, that's what the question is asking. Do we sample 200 people, 300 people, 400 people, 5,000 people? We really want our confidence interval to be pretty small. Okay, so again, Z times p hat 1 minus p hat over n. That thing there, the margin of error has to be less than or equal to 0.01. Okay, so we want it so that the confidence interval has a width of 0.0. So we could say equal to, but we want at least the number of people so that interval is less than that, not more than that. Okay, so this is a, no, it doesn't say, but it will say in any question, it's got to tell you what's the level of confidence for this thing. So let's go for 99% here. So this would be 2.576. You can work that out on your calculator. Now, let's say we didn't do this sample of 100 people first and we didn't know what p hat was. We could actually work out by using 0.5 for our value. That will give us the biggest possible confidence interval, okay? All other values of p, whether bigger or smaller than that, actually make it smaller. So to calculate the minimum number for n that you need, just put p equals 0.5 in there if it's not given, and you'll be able to work this out. Again, the steps are exactly the same as the last one. Let's work it through and I'll tell you the answer at the end. Okay, so I've run through all those calculations there. And I've got 16,164.75. So again, with the inequality, I can see I want n bigger than that. So in order to make sure that the interval is within 1%, the margin of error is within 1%. So I would go with 16,165 people. Now again, would be really great to be able to have the time and money to be able to sample 16,000 people. Very unlikely that you will have the time and the money to be able to do that sample size. Hence, the margin of errors in political surveys are not within 1% because it just takes too many people. They're typically 2, 3, 4% in the margin of error, and it all depends on n, the sample size. So there's some problems using confidence intervals and talking about the margin of error and finding some values there.